Let's talk fundamentally about what arrays are and why we might want to use them. Arrays solve this problem of scalability in our programs. Up to this point, we've been writing programs with small amounts of data, and some of you have mentioned this concept about what happens if, for example, our ATM program had to handle the data processing for, say, an entire bank of customers, not just a single customer. And arrays are going to allow us to do that, deal with, many, many, many thousands of pieces of data. Arrays are just the first foray into this field of data structures, this idea of efficiently organizing data so that we can efficiently compute that data to achieve the goals that we would like to achieve. So instead of, say, having 10,000 variables, one for each student at the college, we could actually declare one array called something like, MC3 students, and then we could actually use a loop to iterate over that single namespace using an index system. In other words, say something like MC3 students 1, MC3 students 2, and then maybe, look for the highest GPA or generate a mailing list. It gives us an efficient way to deal with data. Now, arrays are really similar to lists, and I'm sure you make lists every day. Shopping lists, to-do lists, right? Life goals lists, and so on and so on. So this idea should not be very new to you. So don't look at this and say, oh, this is some really hard programming concept, because really what it is it's just an application of a system that you're familiar with in your day-to-day life that's now just being modified and utilized within a computing system. So again, why do we use arrays? Well, imagine again, if you had to use 1,000,000 pieces of data, what are you going to do? Declare 1,000,000 variables? That would be forever. My variable 1, my variable 2, and so on. So it'd be really nice if we could just say like, okay, here's one variable, and then we could actually use a loop or some other structure, but in this case the loop is the best, to iterate over everything in that list and actually then do something to it. Maybe, verify that they have a phone number or generate a mailing list again. It's a really convenient way to hold data, and it's a way that you've actually been dealing with data for a long time. So it's efficient for data processing. Arrays are reusable in multiple systems, and they're really nice to have. Are arrays as efficient as large-scale data storage systems like databases? Well, arrays are really the beginning of your journey into understanding how we organize data to work with it. So things like linked lists and graphs and trees and a lot of these things you may have heard about in terms of organizing data. This is really the first step you take to start to look at how we can put things together in a unique fashion so that we can have scalable data that can be efficiently computed upon and can efficiently generate the results we want. We don't want to wait a long time, and we don't want the programmers to have to do lots of manual labor to generate the code for us. One quick note is that in Java, arrays are objects. And you'll want to put this in the back of your head for later. So the real takeaway here is just to recall from the video lecture with the cups in it that variables that are declared to hold objects, they don't really hold the object, they just hold a memory address to where the object is located. That's more important with arrays in the sense that they're a list of items, and so really what the memory address is pointing to in our variable is really just the first item in the list, and then from there the system can compute what's at the second position, the third position, and so on. But just if this is still confusing to you, just keep this in mind that what we're talking about here is a system that is using a reference or a pointer. In other words, the variable is holding a memory address of where to find the actual array. A couple other things about arrays before we look at this conceptually. Arrays and data types. This idea of an array being homogeneous, which is just a fancy way to say that arrays can only hold data of a single type. So when you declare an array, you can only have, if you need to store ints or doubles, you're going to need two arrays. One array to hold all ints, and then a second array to hold all doubles. If you want to store strings, you need a third array to store all strings. So when you declare an array, every piece of data in that array has to be of the same data type. Later on in the semester, in the next week or two, we'll talk about this idea of polymorphism, and this really isn't a hard and fast rule, but this week it is. Later on we'll look at how we can get around this. How do you build an array that can hold objects or data of multiple data types, and that's something we'll look at later. But for this week, when you're building your arrays, they can only hold one data type. So just remember, our arrays can only hold data of one type. Alright, so think of an array like a list. You used lists all the time in your life. So in front of you is a piece of notebook paper, and it is called to do. So this is my to-do list. I could also have a list called grocery shopping or whatever, but in this case I've got a list. This is my array. My array has a name, every array needs to have a name. Every list should have a name. Even though you might not explicitly write to-do list on your to-do list, you know in your head that it's your to-do list. I might have a class roster. That's the name of the list that contains all the students in this class. I have a grade book. That is a list that contains all of your grades. So every list needs a name. Obviously, if a list has a name and we have a list, the next item we have in our list is data. And in this case, I have 3 pieces of data. Each one is of type string. We tend to think of lists as being top-down. We tend to think of lists as being ordered. We tend to think of lists as the item at the top as being the most important. Okay, so item 1 is paint house. Item 2 is mow the lawn. Item 3 is cook dinner. What we also know about lists is that they have indexes. So formally, we would say that paint house is the first item on the list. And just because this is computer science and they like to confuse you, the first index is always at item 0, not at item 1. I always tell students, when you're getting these concepts, when someone says, can you count how many people are here? And instead of going 1, 2, 3, 4, you go 0, 1, 2, 3, and you go, oh, wait, no, this isn't a program. You have to remember that programmers most of the time start counting from 0. Why waste a couple of bytes in memory when you can, utilize that 0 value? So item 1 in my to-do list is paint house. Item 0 in my to-do list is paint house. Item 1 in my to-do list is mow lawn. Item 2 in my to-do list is cook dinner. So notice when I give the name of the list, I also give the index number. I can reference the value at that index number. So if I just said to you, what's a to-do list item 1? You would look at the list and say, mow lawn. And if I said to you, cook dinner is at what index on the to-do list? You would say item 2. So notice that we can refer to items in the array by data, or we can refer to them by index. It's actually a little harder to refer to them by data. In all your programs, you're going to say, go to the list name to do, go to index 1, and tell me what's there. Or go to the list name to do, go to index 1, and put some data there. Arrays in computer science have a few weird and interesting attributes. One of them is that once they're created, they can never be resized. So it's kind of a useless, in this case, my to-do list has 3 items in it, and I can never put a 4th item in it. I could delete one of the existing items. I could replace mow lawn with, fix furniture, but I could never have more than 3 items on my list. That's just a unique feature of lists, and you'll see that in the reading. So what does this look like in code if we take that item that I just had previously up? Well, it's a list named to do. It's of type string, and notice that on the left-hand side of the first line here, I've got string bracket bracket. What differentiates the declaration of an array variable over a regular variable are those 2 brackets. Those indicate to the compiler that the variable that you're going to be declaring is of type, it's going to be holding strings, but it's actually an array. On the right-hand side, we use the new operator. We use the term string again to emphasize that this array, this list, will only hold strings, and this list will be able to hold 3 items, indexed 0, 1, and 2. Uh-oh, and I just found a pretty horrible typo in my code. And so I'm going to jump out of this video lecture, and I will actually fix this, and I won't even need to edit. There we go. So look, I've got 3 indexes. My list can hold 3 items. But notice that the first item, paint house, is at index 0, mow lawn is at index 1, and cook dinner is at index 2. So notice that even though it holds 3 items, the first index is 0 and the last index is 2. That is 3 items. It's just that they don't go from 1 to 3, they go to 0 to 2. You'll see this again in the later part of the lecture where I actually write this in code. A couple of things that arrays know about themselves. They know the length of the array, and actually this is a bad worded slide too, so let's go out of this and change that. They don't know the total number of items in the array. They know the total number of items that can be stored in the array. So this is called the length. The length indicates the total number of spaces available for storage in the array. If we were to think of length at the college, it would be the total number of available parking spaces to put cars in, not the number of cars that are parked in the spaces. If you want to know that, you have to keep track of that yourself. So in this case, the length of the to-do array is 3. And if I go back a slide, you'll notice the reason why it is 3 is because that's the length that it was declared with. I can't ever grow it to make it 4. I can't ever shrink it to make it 2. It's always of length 3. Notice that I have 3 positions to store data in. Each one of those positions is full. So in this case, the length of my array is the total number of items that can be stored in the array. The way you ask for this, by the way, is giving the name of the array dot length. Notice there's no parentheses after the word length. Again, when we get to the code section, you'll see that in practice. A couple things about indexes. The first index of an array is always 0. The last index of an array is always length minus 1. So if it's if the length is 3, the last index is going to be 2. If the length is 19, the last index is going to be 18 because we start at 0. Indexes must be positive whole numbers. That's really important. You can have a negative index or an index 2.5. And the only limit that I believe that there exists on total number of indexes, in other words, how big can your array be, is I think you can pretty much make an array that will consume all of your available RAM and memory. So if you have a computer or you want to write a mischievous Java program, I believe you could probably hit the cap, although the JVM is usually pretty good about not hogging up the entire Windows memory allotment. But you could try to see how big of an array you could actually create, and then maybe look at how your memory footprint is after that. One other thing to know, you'll see it in the code section, is that there's another way to make an array that's just a little bit more convenient, again with this idea of many ways to do one thing. These things called Initializer Lists, and basically what they allow us to do is quickly build an array. And notice this is the same thing as my previous to-do list. There's some curly brackets involved. There's still 3 strings here. Paint house is still at index 0. Mow lawn is still at index 1, and cook dinner is still at index 2. But really what this is it's a convenience to allow us to avoid, and I went back into here. So we still end up with this list, right? But it allows me to avoid typing all of this stuff. So this is the way you should probably start writing your arrays in the beginning. But as you get more comfortable with it, you could move to initializer lists when you have a set of default values you want to put in the array. Because it's just less characters, it's less pain on your wrists, it's less possible, of getting carpal tunnel. So just as a reminder, this is the list we looked at. It might be worthwhile to go ahead and actually go and explore how to build this on your own. And in the next part of the lecture, we'll actually build some arrays. And you'll see me actually writing the code, and we'll look at how to iterate through the list, how to print items out of the list, and just basically a supplement to the reading to get a little bit more familiar with utilizing and working with lists. A little quick tip before we go into that. If we want to access an item in a list, I just give the name of the list and then the index number of that item, and it'll print that out. Notice in this case I'm just saying go to list to do, grab the item at position I, and print it out. Well, where did position I come from? Well, check it out. For loops work great with arrays. We always know that an array's first index is 0. We always know that its last array that we know the length of a list, in this case to-do.length. Notice I'm saying I is less than to-do.length, so that would be 1 less than the overall length of the array, which is the last index of my list. Remember, the length of the to-do list is 3. The last index is 2. So as long as I is less than 3, it's still a valid index. And each time through, I just increase the value of I. So for loops and arrays are meant to work really, really well together. And you'll see in the code examples that they do. A lot of the assignments in this chapter are combining loops and arrays in creative ways with things like scanner objects and if statements and variables to achieve the goals that we want to achieve. So remember, we're putting these building blocks together now in creative ways to solve problems. In this video lecture, we're going to walk through the fundamentals of using arrays. We're going to look at single-dimensional arrays. We're going to look at how to add things to a single-dimensional array, how to read items from a single-dimensional array, and we're also going to look at, obviously, how to create single-dimensional arrays. So let's get started. I've got a framework for a Java application here, and we will use the scanner object later. I just wanted to set it up. Just like any other object we utilize in Java, we need to go ahead and create our array. And from the other video lecture, you'll note that an array is just a simple way of utilizing a single namespace to hold many values. Okay, and let's go through and look at the process of creating an array. First thing we need to determine is what type of data our array is going to hold. Arrays can only hold a single type of data. In other words, they're homogeneous. All of the values inside of an array have to be of the same data type. Later on, we'll look at how to get around this through the use of polymorphism and objects. But for right now, we'll look at arrays that hold either all integers or all doubles or all strings. So let's go ahead and create the array. I'm going to call my array my int array, so it'll be pretty easy to create. And I'm going to use the new operator. Now, a couple other things that we need to remember is that when we create an array, and actually let's go in here in the code and make some comments. So we'll say that arrays are homogeneous, that way we've got that down. They can only hold one type of data, and in this case our array holds ints. The other thing we want to do is know that arrays are a fixed size, and once created, they can't be resized. And so let's go through and see how we're doing this. I utilize the int keyword to indicate that my data structure, my array, is going to hold nothing but integers. The brackets here indicate to the Java compiler that the variable that I'm creating is an array and not a regular integer variable. In other words, set up memory in such a way that I can hold a list of integers and reference them by index. The name of my array is going to be my int array. On the right-hand side of the assignment operator, I'm going to use the new operator, which we know is there for building objects. The underlying mechanisms for arrays in Java are objects, and we'll be talking more about objects moving forward. But the new operator, remember, takes blueprints for an object and actually creates a new version of it, or creates an actual instance of that object. So in this case, I need new. Next to the new operator, I again indicate that this array will hold nothing but integers. And then I've got a series of brackets as well. So this part of the this part of the array creation looks very similar to what's on the left-hand side of the assignment operator, with one difference. Inside of the brackets on the right-hand side of the assignment operator, we need to indicate the size of our array. And I'm going to go ahead and indicate that we should put 5 things in my integer array. Okay, so the number between brackets on the right-hand side of the assignment operator indicates the length of the array. And we do reference the length of the array. One other thing about this array has a length of 5. The indexes to this array are 0 to 4. And we can generalize that as array indexes, or indices. I'll just go with indexes. Let's say the smallest array index is always 0, and the largest index is always going to be length minus 1. And that should look a little bit familiar to dealing with strings too, when we've talked about accessing individual characters in strings, because the underlying data structure abstracted to you by objects, but for a string, the underlying data structure is actually an array. So a couple things about our array. The name of my array is int array. The brackets over here indicate that this will be an array to the system, not a regular variable. The data type for this array is of type integer. On the right-hand side, we need the new operator because the underlying implementation of arrays in Java is the object system. We indicate again the type of data to be stored in this array. It's almost like a double check system. And then the brackets here contain a single integer value. And in this case, the integer value tells the compiler, tells the system how big to make the array. In other words, what the length is. One other thing that's important, array indexes must be whole numbers and positive. So we can't have like a negative array index. So just a couple rules. Again, if you wanted to create a double array, the only thing you would need to change is change this to double, change this to double, and probably give it a more appropriate name. Let's go ahead and play with this. So let's assign some values to the array. So the way we do this is we indicate the name of the array, and then we indicate the index where we want to put an item. And I'll say at index 0, I'd like to put 20. At index 1, I'd like to put number 21. Let's skip an index, by the way. And let's say at index 4, I'd like to put the number 22. So what I'm essentially saying here is go to this list, go to index 0, and insert the number 20. Go to this list, go to the index 1, and insert this value. Skip index positions 2 and 3, and go to this array, go to index 4, and input this value. So that's how we can assign some values to the array. How do we print out array values? To print out a single value, it's very similar to assignment. We just simply give the name of the array and the index that we want to view. And I'm going to go ahead and compile this because inevitably I might make a typo as I'm writing this. And everything compiles correctly. So the only thing I have in my code right now is I create an array, and I'm putting some values into specific slots in my array, and then I'm going to print out one of those values so we can see what's there. And it tells me that the item at position 0 is 20, and that's acceptable because that's exactly what I put there. Now you might be saying to yourself, you didn't put anything in index 2 and 3. What's at index 2 and 3? Well, let's find out. Notice that I'm going to ask for the value at index 2, but I never actually assigned a value to index 2. So let's go ahead and run this and see what I get. Guess what? I get 0. One of the things that Java does that not necessarily every other language does is when you create an array, it actually sets all of the values in your array to some default value. In the case of integers, the default value is 0. In the case of doubles, it's 0.0. In the case of strings, it's the empty string. I don't know what it is in the case of characters, but you could find out. So notice, even though I put nothing into array index 2, I still got 0 to print out because that is a default value. In other languages like C, you would actually need to go through the process of making sure that you put valid values in each of the array indices. Otherwise, you would just get whatever value was in that part of memory before. But Java actually zeroes everything out for you, which is very nice. And then the next question would be, 4 is my biggest index, so what if I try to print index 10? Notice that my array only has a length of 5. Therefore, it only has indexes 0 to 4. So what happens if I try to access an invalid index? Notice that my code compiled, but notice that I get an error. And the book discusses this error, and we've seen this a little bit with working with strings, but notice I get an array index out of bounds exception. That exception always, always, always means that you're trying to access an index that exists outside of the number of available indexes in your array. It'd be kind of like if you bought a ticket to go to the theater, and when you got there you realized that you had row F17, but row F only went up to seat 16. You'd be really angry because they sold you a seat that didn't exist. In this case, what happens is if we try to print an invalid index, we get an error. So let's put 2 back down there. Let's put 1 back in there for when you play with this. And I'll put here, what if you access an index of an array that doesn't exist? And what we'll do is we'll actually print. I'll actually put that exception in here so you've got it. But you should be playing around with this stuff because you can't really hurt the computer playing around with arrays. And what I'm going to do is put this in here. And now what you'll notice is if you want to play around with this, you'll see that I've got the code that triggers the exception. Notice it tells you the index array exception. Notice that it also demonstrated to me originally that this was on line 29. Notice now it's moved to a new line. But remember, error messages always try to give you an idea about where in the program the error is executed. There's a convenient way. Let's create another array here. This time let's do a string array. Okay, call it my friends. And notice I forgot the brackets, so it's not actually an array. So the difference between a single array variable and brackets, or sorry, an array are these brackets, simply put. So if you forget them, the computer doesn't know it's an array, it just thinks it's a regular variable. So always remember those hard brackets. And I'm going to go ahead and create a string array. Now, up top here, when we made the int array, we physically declared the size of the array. We said, look, reserve me memory for 5 specific locations that I can do some work with that. But now, in my new case, what I want to do is I'm going to actually do something different. So we could go ahead and we could add something like this, and we could go ahead and we could put in our names like we did before. We could say like my friends, 0 equal Jason, but we don't want to do that. So we're going to get rid of all of this. And we're going to use what are called initializer lists. So initializer lists make, initializing array variables easy. We won't use initial. Make setting up default array values easy. So in this case, let's add some things in here. Jason, Andy, Bob. All right, so there's an array with my friend. Now notice the syntax of an initializer list. It's a little bit odd. There's no new operator. We never indicate the length of this array, and let's see if we can get the other one into the same window so we can compare the two. So notice the left-hand side of the assignment operator, when we created the int array, looks exactly like the left-hand side of the assignment operator building the string array. Where the difference is on the right. What this did is it set up some memory. There was nothing in the memory, and it just reserved 5 spots in memory. What this is doing is, because I know that I want to put stuff in those spaces ahead of time, this allows me a very convenient way to set things up without having to go through typing these lines of code. Because you can imagine if I had like 20 or 30 things to add to the array, this is just a lot of extra typing. So what this is a convenience to allow us to put values into an array really quickly. So what does this mean? Well, notice a couple things. Let me compile it, because inevitably I forgot the semicolon at the end of the line. So I wanted to make sure I forgot that. Remember, I've been programming in Objective-C a lot lately. So on the right-hand side, what do we got here? I've got a string, a comma, another string, a comma, and another string. Notice that these are strings. These agree with the data type. In other words, this array can only hold strings. These are curly brackets, not parentheses and not hard brackets. It's a very specific syntax thing that you just have to remember and memorize when you use initializer lists. The comma separates each component in the list. So Jason is going to be at index 0 of my array. Andy is going to be at index 1 of my array. Bob is going to be at index 2 of my array. So what we know here is that the my friends array has a length of 3. Jason is at index 0, and we'll actually spell this out. Andy is at index 1, and Bob is at index 2. And if we want, we can do is, and I'm just going to copy this to save typing. We'll change this to my friend 0. We can still access the values in the array the same way. We'll just have to watch both programs run. But what you'll notice is there's no difference. It says the item at position 0 is Jason in this array. So it's kind of convenient, and it's just a really nice way to set up default values for an array. Again, initializer lists are just a shortcut for this basically verbose method of assignment. All right, with that said, let's look at some additional uses of arrays. Use a loop to print out every item in an array. We normally use for loops when dealing with arrays because for loops are very good for loops when we know where the loop starts and where the loop stops. So let's just indicate that. Remember, we use for loops when we know where a loop starts and stops. Let's set up a for loop. For I equals 0. I is less than something, because we haven't gotten there yet, and I plus plus. And I'm setting this up as a default array. I want to print each item in the array from the beginning to the end. Well, I've got the variable I. It starts at 0. Why does it start at 0? Because the first thing in my array is at index 0. Now, what is the last thing in my array at? Well, we can actually ask an array how long it is. And so whenever you're looping through an array, you indicate that by using dot length. And we'll put a note in here that says, each array knows how long it is. And you just ask. And one odd thing to note is, note that length has no parens after it. So again, length is actually a property of the array. It's not a method. And something, again, we'll look at in more detail next week. So my array starts at 0, and it's going to print out every position until it gets to length. And I'm not going to change that, but hopefully you're screaming at the lecture right now saying, hey, there's an error there. Let's go ahead and print this out. Position and I'm going to build a string here so it's easy to see this. Inevitably I might miss a plus sign here. So what I've got here is a print statement. I'm going to print out that we're looking at position 0, and then I'm going to print out the value contained at position 0. Hey, and I actually got the syntax right. So let's go ahead and print this. And my item at position my friend 0 is Jason, item at position my friend 1 is Andy, item at position my friend 2 is Bob. Oh, and I automatically did not generate an error in that code. I was trying to make an error, but it's a difficult one for me to make. So let's look at what my output was. Item at position my friend 0. How did I get that? It's a string. Item at position my friend is, if I spell it correctly, I print out the current value of I, so notice 0, 1, and 2 are generated by that value of I, and then I concatenate the value stored at that index in the array. So 0, 1, and 2, I get Jason, Andy, and Bob concatenated to that string. Notice up here I said I is less than friend's length. What if I made that I is less than or equal to friend's length? Well, remember that our first index is 0, our last index in this case is 2, and the length of our array is 3. Remember that the length of an array is always one more than the last index of the array. So what if I make that less than or equal to? I get an index out of bounds error. Why? Because it got to 0, it got to 1, it got to 2. The loop comes back up and it says, well, less than or equal to the length, and the length is 3, so 3 is equal to 3, and therefore the loop will continue to execute, and I get an out of index exception with 3. So you can either do what I would normally do is I is less than my friend's dot length. You'll notice that as I tried to code an error into the code, my brain was not even willing to let me enter that error because it's just something that we normally do. If you want to print through an array backwards, by the way, just start at the end and go forward. So all I'm going to do is set I equal to my friend's dot length minus 1, which will be the last index, and while I is greater than or equal to 0, and we'll subtract 1 from I. And now what that'll do, oops, and I think I moved the window, sorry about that, guys, is actually go ahead and print the array backwards. So the first loop prints everything 0, 1, 2, and then the second loop prints it 2, 1, 0. So with this code, there's a couple of questions that I ask you to take care of. You should be able to use loops now to read through arrays, just print them out. The other thing you need to start thinking about is how you integrate loops into things like prompting a user for input, right? Assigning values inside of loops. Loops and arrays go together I could probably make some cheesy joke about a song or something, but they go together very, very well. And you'll notice that we really do need loops to iterate through arrays if we want to get all the values. So you need to be comfortable with these really fundamental basics. And so let me know if you have questions about anything related to loops. I don't want to go much beyond this because the problems that I give you are very, very they may appear to be difficult, but what the goal again is to take the fundamental components that we've learned up to this point, combine them in a unique way to solve the problems at hand. So I'll put this code up with the lecture, and please ask if you have questions.